Hello everyone, welcome again. In this video, I am going to discuss two more important examples on inverse Z transform using partial fraction method. So our first example is find the inverse Z transform of U bar Z which is equal to Z upon Z minus 1 into Z minus 2 for the region of convergence mod Z greater than 2. So we have to find inverse Z transform of given U bar Z for the region of convergence mod Z is greater than 2. Given U bar Z is Z upon Z minus 1 into Z minus 2. Now first we apply the partial fraction technique or partial fraction method on U bar Z. So using the partial fraction we can write the partial fraction of Z upon Z minus 1 into Z minus 2 is A upon Z minus 1 plus B upon Z minus 2, because both the factors are linear and non-repetitive. So we write A upon Z minus 1 plus B upon Z minus 2. So this is the partial fraction of U bar Z. Now we have to find the values of constant A and B. So we take LCM, and here LCM is Z minus 1 into Z minus 2. Then LCM cancel both sides. And here we have A into Z minus 2 in numerator plus B into Z minus 1. So after cancellation of LCM in both sides, this expression is equal to Z equal to A into Z minus 2 plus B into Z minus 1. Now for Z equal to 1, this expression is 0. So for Z equal to 1, we get 1 equal to here A into 1 minus 2 is minus 1, and for Z equal to 1, this expression is 0. So this gives the value of A is minus 1. Now for Z equal to 2, this expression is 0. Therefore we get for Z equal to 2, 2 equal to this expression is 0 plus 2 minus 1 is 1. So we get B into 1, and which gives the value of B is 2. So we get the values of constant A and B. B is 2 and A is minus 1. So putting the values of A and B here, we get U bar Z. This is U bar Z. So we get U bar Z is equal to the value of B is 2. So we write 2 upon Z minus 2 plus the value of A is minus 1. So we write minus 1 upon Z minus 1. So this we complete the partial fraction of given U bar Z. Now by region of convergence, the region of convergence is what? Mod Z is greater than 2. So 2 by Z, mod Z is greater than 2. Therefore 2 by Z mod is less than 1. So we have mod 2 by Z is less than 1. And therefore we expand this expression in terms of 2 by Z. In binomial expansion, we expand this term, this function or this expression in terms of 2 by Z, because mod 2 by Z is less than 1. Further, mod Z is greater than 2 and 2 is greater than 1. This implies mod Z is greater than 1, and which implies 1 upon mod Z. 1 upon mod Z is less than 1. So we get we have to expand this function from we have to expand this expression in terms of 1 by Z using binomial theorem. So region of convergence suggests that we have to expand this expression by binomial theorem, but in terms of 2 by Z, and this expression using binomial theorem we have to expand in terms of 1 by Z. So here we take z common, then we get in denominator we take z common, then we have 1 minus 2 by z, and here we take z common, then we get 1 minus 1 by z, and 1 by z mod is less than 1. So we write u bar z equal to, here from denominator we take z common, then we have 2 upon z into 1 minus 2 by z, and because 2 by z mod is less than 1, and minus 1 upon, here we take z common from the denominator, then we get 1 minus 1 upon z, because 1 by z is, mod 1 by z is less than 1. Now these two expression we write in the numerator with inverse power. So we have u bar z is equal to 2 by z into 1 minus 2 by z whole inverse minus 1 by z into 1 minus 1 upon z whole inverse. Now we expand these two expression using binomial theorem, and as we know, the binomial expansion of 1 minus x whole inverse is 1 plus x square plus x cube plus so on. So the binomial expansion of these two expression is u bar z equal to 2 by z as it is. Now binomial expansion of 1 minus x whole inverse is 1 plus x is 2 by z, plus x square is 2 by z square, plus x cube 2 by z whole cube, and so on. So 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube, and so on. This is binomial expansion of 1 minus 2z whole inverse. Minus 1 upon z. Now again we have 1 minus x whole inverse. So binomial expansion of 1 minus x whole inverse is 1 plus x is 1 by z, plus x square is 1 by z whole square, plus x cube 1 by z whole cube, and so on. So we have 1 plus 1 by z plus 1 by z whole square plus so on. So these are the binomial expansion of these two functions. Now we multiply this 2 by z with these all term and 1 by z with these all term. We get u bar z is equal to 2 by z plus 2 by z square plus 2 by z whole cube, and so on, minus, here we have 1 by z into 1 by z plus 1 by z into 1 by z whole square, plus 1 by z into 1 by z whole square is 1 by z whole cube, and so on. Now we express these two series in terms of summation. So this term is 2 by z power 1 plus 2 by z power square plus 2 by z power whole cube. So we write summation 2 by z power n, where n start from 1, 2, 3 and infinite. Therefore, in form of summation, we write u bar z is equal to summation n goes from 1 to infinite 2 by z whole power n. For n equal to 1, we get 2 by z, plus for n equal to 2, we get 2 by z square, plus for n equal to 3, we get 2 by z whole cube, and so on, minus this series we write summation n goes from 1 to infinite 1 by z whole power n. So for n equal to 1, we get 1 by z, plus for n equal to 2, we get 1 by z whole square, plus for n equal to 3, we get 1 by z whole cube, and so on. So we express these two series in terms of summation. Further we write u bar z is equal to summation n goes from 1 to infinite. This is 2 power n upon z power n. So we write 2 power n into z power minus n in numerator, minus summation n goes from 1 to infinite. This is 1 power n upon z power n. So we write 1 power n into z power minus n. So both summations varying from 1 to infinite, and we take z power minus n common, then we can write in single summation this expression as u bar z is equal to summation n goes from 1 to infinite z power minus n common, then we have 2 power n minus 1 power n is 1. Now as we know, u bar z is summation un z power minus n. Z transform of un is u bar z, and which is summation un z power minus n. So inverse z transform of u bar z is what? Un, and which is the coefficient of z power minus n. So here the coefficient of z power minus n is un, and which is the required inverse z transform of u bar z. So un is the inverse z transform of u bar z, which is un, and which is the coefficient of z power minus n, which is 2 power n minus 1 for n greater than or equal to 1, because n is varying from 1 to infinite. So n is greater than equal to 1. So this is the required inverse z transform of given u bar z using partial fraction method. Next example is, find the inverse z transform of u bar z is equal to 15z upon 4 minus z into 4z minus 1 for the region of convergence 1 upon 4 is less than mod z is less than 4. So given u bar z is 15z upon 4 minus z into 4z minus 1. Now we transfer this z in left hand side, then we get u bar z upon z is equal to 15 upon 4 minus z into 4z minus 1. Now we apply the partial fraction method on u bar z upon z. That is, on this expression we apply the partial fraction. So the partial fraction of 15 upon 4 minus z into 4z minus 1 is a upon 4 minus z plus b upon 4z minus 1, because both factors are linear and non-repeated. So we have a upon 4 minus z plus b upon 4z minus 1. So this is the partial fraction of u bar z upon z. We have to find the values of constant a and b, and for that we take LCM, then LCM both sides cancel. Here in numerator we get 15 after cancellation, and here we get in numerator a into 4z minus 1 plus b into 4 minus z. So after taking LCM and simplification, we get 15 equal to a into 4z minus 1 plus b into 4 minus z. Now for z equal to 4, this term is 0. Then we get for z equal to 4, here we have 15 equal to a into, for z equal to 4 into 4, 16 minus 1, 15, and then 15 cancel, we get the value of a equal to 1. Now for z equal to 1 by 4, so 1 by 4 into 4, 1, and 1 minus 1 is 0. So z equal to 1 by 4, we get 15 equal to, this expression is 0, plus 4 minus 1 by 4, we get 15 by 4. 15 cancel, and we get the value of b is 4. So we find the values of a and b. A is 1 and b is 4. So the partial fraction of u bar z upon z is this, for the value of a 1 and for the value of b is 4. Therefore we write u bar z upon z, u bar z upon z is equal to a is 1, so 1 upon 4 minus z, plus b is 4, so 4 upon 4z minus 1. So this we complete the partial fraction of given u bar. Now u bar z is what? We get u bar z is z upon 4 minus z plus 4z upon 4z minus 1. So this we complete the partial fraction of u bar z. Now the region of convergence is 1 upon 4 is less than mod z, which gives 1 upon 4z mod is less than 1. So we have to expand this expression using binomial theorem in terms of 1 upon 4z, and therefore we take 4z common, then we get 1 minus 1 upon 4z. Further, the reason of convergence is mod z is less than 4, which gives z by 4 mod is less than 1. So, we have to expand this expression using binomial theorem, but in terms of z by 4, because mod z by 4 is less than 1. And therefore, we take 4 common from here, then denominator, then we get 1 minus z by 4. So, reason of convergence suggests that the expansion of this term is, this expression is in terms of 1 upon 4z, and the expansion of this expression is in terms of z by 4. And for that, here we take 4 common and here we take 4z common. Then we get u bar z equal to z upon, in denominator 4 common, then we have 1 minus z by 4, plus 4z upon, in denominator 4z common, then we get 1 minus 1 upon 4z. So here we transfer these two expressions in numerator with inverse power, then we get u bar z is equal to z by 4 into, in numerator we get 1 minus z by 4 whole inverse, plus here 4z cancel, and this expression in numerator we get 1 minus 1 upon 4z whole inverse. Now expand these two expressions using binomial theorem. So binomial theorem, binomial expansion of 1 minus x whole inverse is 1 plus x square plus x cube plus x power 4 and so on, and here x is z by 4. So using binomial theorem we get u bar z is equal to z by 4 as it is. Now the binomial expansion of 1 minus x whole inverse is 1 plus x is z by 4, plus x square, so z by 4 whole square, plus x cube, z by 4 whole cube, and so on, plus, now again binomial expansion of 1 minus x whole inverse is 1 plus x is 1 upon 4z, plus x square, that is 1 upon 4z whole square, plus x cube, and so on. So these are the binomial expansion of these two functions. Now multiply z by 4 with these all terms, we get u bar z is equal to z by 4 plus z by 4 whole square plus z by 4 whole cube plus so on, plus here we write as it is. Now we express these two series in terms of summation. So here z by 4 power 1, z by 4 power square, z by 4 whole power cube. So we can write summation z by 4 whole power n, where n start from 1, 2, 3 and so on. And here we have u bar z summation z by 4 whole power n, where n is starting from 1 and goes up to infinite. For n equal to 1 we get z by 4, plus for n equal to 2 we get z by 4 whole square, plus for n equal to 3 we get z by 4 whole cube and so on. Now here this is 1 by 4z whole power 0, this is 1 by 4z whole power 1, this is 1 by 4z whole power square and so on. So we can write summation 1 by 4z whole power n, but n start from 0, because for n equal to 0 we get 1, for n equal to 1 we get 1 by 4z, for n equal to 2 we get 1 by 4z whole square and so on. So summation is varying from 0 to infinite. So we express these two series in terms of summation. Now further we can express u bar z is equal to summation n goes from 1 to infinite. Now this is z power n upon z power 4n. So we write z power negative 4n in numerator, plus summation n goes from 0 to infinite. Here 1 upon 4 power n we write 4 in numerator 4 power minus n, and z 1 upon z power n we write z power minus n in numerator. Now as we know un is the coefficient of z power minus n. This is z power minus n, but this is z power plus n. So in this first summation we replace n by minus n. Then in first summation replace n by minus n, we get u bar z, these all terms become negative, so n goes from -1 to minus infinite, because all n become negative n. So we have n -1 to minus infinite. 4 power plus n, because n is minus n, then we have 4n into z power minus n, for n replaced by minus n, and this we write as it is. Now we collect the coefficient of z power minus n, which is required un, that is inverse z transform of u bar z. So we have un is equal to 4, coefficient of z power minus n is 4 power n, for n less than or equal to -1, because n is varying from -1 to minus infinite. So un is 4 power n for n less than or equal to -1, and un is 4 power minus n, coefficient of z power minus n is un. So un is 4 power minus n for n greater than or equal to 0, because n is varying from 0 to infinite. So this is the required inverse z transform of given u bar z using partial fraction technique. In next video we will take next method of finding inverse z transform, which is partial fraction method with direct formula. So see you in next video. Thank you.